Hey, math people! It's time for lesson 83 or something. I gotta get this bird. We gotta go this way. Yeah. All right. Well, today we're gonna do factoring special products, and you know what I mean when we say special, right? I really mean special. So, righty then. I really like this stuff, man, because I'm pretty special too, you know. Today, you're gonna probably want to have your algebra property sheet. There are some right down in here today that we're gonna explore. Um, I call them shortcuts. Some people call them factoring, and yeah, since we've been doing a lot of factoring recently with trinomials, of quadratics, and those kinds of things. Today, as an extension of that, we're going to look at some special patterns or some special cases of factoring where you can pull a quadratic apart into its pieces. Or at least we're going to see the patterns. Can't do that the whole time. Oh, my goodness. Ah, that's, it's empty. I'm just kidding. All right. So, are you ready? You shouldn't. You shouldn't keep going unless you're ready, because I'm ready. What I want to do here is I want to look for a pattern in the products. Products means I'm going to have to multiply. I'm going to take something, and in this case, x plus 1, and I'm going to multiply it by itself, squared. Okay, I'm going to do this with several of them, and then we're going to see if we can figure out maybe what the next one should be when we do the multiplying. So using the FOIL method, this one turns into, I could do it in the long version here, x squared plus 1x plus 1x plus 1, or x squared plus 2x plus 1. Y'all agree? Maybe you can't even see that, but it's true. It's what it is. X plus 2 squared is x plus 2 times x plus 2. And we get x squared plus 2x plus another 2x. And at the end, we get 2 times 2 is 4. Okay, nothing terribly exciting there yet, but we're going to keep going. We're going to see if we can extend the pattern and pick up on what's really going on here. So this one's x squared. Every single one's going to start with x squared. And then we got plus 3x plus another 3x. That's 6x. And then at the end, we get 3 times 3 is 9. You're starting to see some patterns here. Maybe. The next one, x plus 4 times x plus 4 equals x squared plus 4x plus 4x plus 4 times 4 is 16. I know what the next number is going to be. Besides just 5's here. X squared plus 10x plus 25. You see a pattern emerging out of this? You should. And we're going to look at the first part, of course, that all of them start with x squared. The ends are all perfect squares because we're squaring 1, we're squaring 2, we're squaring 3, we're squaring 4, we're squaring 5. So all these numbers at the end end up being perfect squares. The next one, if I did x plus 6, it'd be a 36 at the end. But look at what we've got in the middle. On the first one, I showed you that this is 1 plus 1. The second one, I said that it was 2x plus 2x gives us 4x. The third one would be 3x and 3x is 6x. 4x and 4x is 8x. And 5x and 5x equals 10x. So this middle part here is always 2 times x and that number there. Okay? And okay, let's just call it n. Always in the middle, I got 2 twice of x and the number. So there's a pattern sitting there. If I was going to generalize this pattern, okay, cut out all this stuff and just make it something generalized, like let's do x plus, I don't know, c. How about that? Equals x plus c times x plus c. And then we finally get x squared plus cx plus cx plus c squared, or x squared plus 2 of these things plus c squared. So here we go. Here's our general pattern. Now in the book, they'll have it as a and b. Okay, instead of x like we've been doing with our polynomials. And that would give us a squared plus 2 times a times b, 2 of a b's, and b squared. I think that's the way that your sheet has it. Your property sheet has it. Oh no, it has x's and a's. All right, this is an alternate version of that. And this is pretty clever because if you have, this is one quick way to square numbers. If you have something like 22, you can square 20 and you can square 2. 20 and 2 would be the square root of 22. You could throw those numbers in. Okay, so let me do it like this. 22 is 20 plus 2. We want to square 22. We could go 20 squared plus 2 times 20 times 2 plus 2 squared. 400 plus 4 times 20 plus 80 plus 4. 484 would be your answer there for that if you use this process. Because sometimes 22 is hard to do in multiplication. So we got our first pattern there. If we're multiplying something by itself there, we're going to get that pattern where we have twice in the middle of the two pieces on the outside. Remember, this was x squared, and then in the middle we get twice of x and 1. And at the end, we got that number squared. Okay? We get the number squared. If we flip that around just a little bit, we do maybe minuses in there. Okay, well, I'm going to skip to the middle ones here. I'm going to skip to 3s and 4s. X minus 3 squared means this. And when we do the math here, we get x squared minus 3x minus 3x. And then negative 3 times negative 3 is a positive 9. So really nothing changes there at the beginning and at the end when the sign is different, when it's negative and positive. The only part that changes here is now it's negative 6x plus 9. When we did this up here, this one was x squared plus 6x plus 9. The only difference here is that right there. Even though it's a completely different problem, only one sign is different in the answers. X minus 4. Okay, well that's x minus 4 times x minus 4, x minus 4 squared. We get an x squared minus 4x minus 4x. And then negative 4 times negative 4 is a positive 16. We still are getting perfect squares at the end. But in the middle, we're getting twice of x and the number. X squared minus 2ax. Call this a here, plus a squared, or b, or whatever number letter that you want it to be. That's a pattern as well. So I could jump way ahead in the pattern, and I could go to something like x minus 10 squared, and I know what the pattern is going to be like. I'm going to have x squared at the beginning. I'm going to have a perfect square at the end. And then in the middle, I'll have minus twice of x times 10. Twice of x and 10. I don't need the middle step. Honestly, I don't need to do all those extra steps in the middle because I already know where this thing is going. Okay, there's our two first ones. Those ones are located right here. Sorry, the second and the third ones on the common factoring examples on your properties sheet down yonder in this area right here. Okay, the next one that I'm going to do will be one of my favorite ones. Let me just briefly talk about this business because we're not always wanting to do this and go that way. sometimes we're starting with something that's in like the polynomial form. Maybe something like x squared plus, let's just use one that we already had there, 10x and 25. We already something, and if we recognize that that's in a form where we've got a perfect square here at the end, that's 5 squared. And in the middle, I've got twice of 5 times x. Then I can automatically go backwards and say, well, that must be x plus 5 squared. I can automatically put it in kind of a compressed form rather than the other way around. So we can do this. Something like that, and go backwards and just put it in its factored form, which is awfully convenient. And likewise, if I had minus 2ab plus b squared kind of form, I could just ship it right back into a minus b squared pretty quickly. Alrighty, now I need to hit these ones that are the favorite kinds. Oh no, I don't. I'll have to do a separate video on my favorite kinds since I'm running out of time. Recognize whether something's a perfect square. It's super important. So you look at the end and you go, oh, that's 3 squared. Alrighty, well, if that's 3 squared, is the middle part 2 times 3? Then if it is, then I can use my factoring form and I can simplify that. That must be x plus that perfect square. There you go. Take that quickly. And you get another one, and maybe you got to double check on it. You're like, oh, plus 4 is a perfect squared. It's 2 squared. Is the middle? Oh, it's minus. Okay, well that could be. Is it 2 times? No, it's not. It's not that. It doesn't fit the form. So this one right here is not not a perfect square type of problem like an x minus 2 squared. There's something else going on there. We may not be able to factor that very well. Right. One more that they give you, which looks a little bit scary, but that's only because there's a bigger number out there in front. But if I can write that first part as something squared, then I think I'm okay. So I'm going to rewrite this 36x squared as 6x squared. And that'll be just like a or x. It's just a bigger thing in there. And down here, I've got 4 squared. So if this is a perfect square type of problem, then I should be able to do this. 2 times 4 times 6x. If it's true, then I have the perfect square kind of set up. It fits the same exact form, even though it's a little bit more complicated. Like, let's call 6x a. Okay? That would be like a squared. That's all. And I'd have minus 2 times that perfect square times a. Well, that's no different, right? I'm just going to replace that a with a 6x. So it does fit the form. It tells me that the first number is a 6x, and the second number is a minus 4. There's a factored form for that problem right there. That's one of the factored forms. Let me show the other one before we run out of time and I have to do another one. Same problem, 36x squared minus 48x plus 16. And notice that all these are divisible by 4. So if I do that, I get a simpler problem that I can then go ahead and factor out, because there's 3x, there's negative 2 times 3x times 4, that makes the 12, and then I get a perfect, or sorry, 2 times 2 times 3x, and I get a perfect square over here, 2 squared. So this one can be factored down into 3x minus 2 and another 3x minus 2, or 3x minus 2 squared. That's an alternate version of that, 4 times 3x minus 2 squared. Okay, tune back in for the next episode for the difference of 2 squares.